How's it, grade 12s? Today we're going on to tangent to a curve. I'm working from slides 33 to 41, which have been uploaded to your teams, or you can just follow through in your handout. Okay. So before I start actually going on to these slides and stuff like that, I just want to explain what is actually happening here when we find a tangent to a curve. So let's just say that we've got some type of graph here. Okay. Let's say that it's a cubic, right? Now, you're going to be drawing these things later on, all right? So that is what a cubic looks like. Now, that's beside the point. What I want to talk about is tangents, okay? So, for example, if I choose a point over here, now you know that a tangent is a straight line that touches the graph at one point. So that would be the tangent at that point there, okay? And because it's a straight line, it has the equation y is equal to mx plus c, okay? Now remember what we've been doing with this whole time. We've got the derivative, okay? And the derivative is the gradient at a single point. So at this point over here, whatever x value this is, I know the gradient at that point would be f dashed of x, okay? So it's just the derivative of the normal function. That would be my gradient, okay, for my straight line, or in this case, the tangent, okay? To find the c value, we just substitute the coordinate in here. So whatever x, f of x is, we substitute in here and we find what the c value is. Okay, so what I'm going to do is I'm going to go through an example so you can see what's going on here. So example 1 from your notes, it's saying, determine the equation of the tangent to the curve f of x is equal to x squared plus 3x minus 4 at the point where x is equal to 2. Okay, so the first thing I need to do is I need to find my derivative. Okay, to find the derivative, we'll find the gradient, okay, at a point. So the derivative here would be f dash x is equal to 2x plus 3. But now we're interested in a particular point, which is x is equal to 2. So the gradient will be equal to f dashed of 2. So I'm going to take my x value of 2, put it into here, and that will give me the gradient of the tangent at that point. Okay, so I know what my derivative is. So it's 2 times 2 plus 3, which gives us 7. So the gradient of the tangent is 7. So we've got this y is equal to mx plus c, which is the equation for a tangent. I now know what my gradient is. It's y is equal to 7x plus c. But how do we find the c value? Well, what I'm going to do is I'm just going to use the original function to find out what my y value is. So you know that y is equal to f of x. So y is equal to f of 2. So I'm going to take my x value, plug it into here, and then that will give me my corresponding y value to this x value. So we get 2 squared plus 3 times 2 minus 4. So that will give us 4 plus 6 is 10, minus 4 is 6. So the point of contact is when our x value is 2, our y value is 6. That is the point of contact. Okay, now in order to find the c value, I'm going to take this point, plug it into my x and my y. So y value is 6, so we get 6 equals 7. Our x value is 2 plus c. So this is going to give us 14, so it's 6 minus 14, and we get c is equal to minus 8. Therefore, the equation of this tangent is y is equal to 7x minus 8. Okay, let's go on to example 2. So example 2 says, at a certain point on the curve, y is equal to 3x squared minus 5x plus 6. The gradient is 1. Calculate the point of contact and hence determine the equation of the tangent. So now we're working backwards because they told us that the gradient of the tangent is equal to 1. Okay, now remember what that is. So it would be the derivative of this. Okay, so I know that dy dx would be equal to 1. Now guys, don't get confused with the notation. This is exactly the same as saying f dashed x. Okay, the only reason why I have to use dy dx is because they're given it to me in the form y. All right, so now I know that dy dx is equal to 1. What I can do now is let me actually find out what dy dx is from our original one over here. So we know that dy dx is equal to 6x minus 5. Okay, now have a look here. We've got an expression for dy dx over here and over here. So if I set this equal to that, that will give me the corresponding x value that will give me a gradient of 1. Okay, so 6x minus 5 equals 1. 6x is equal to 6, so x is equal to 1. Therefore, when my x value is 1, we will have a gradient of 1. Okay, so calculate the point of contact. So we've got our x value. I just need to find the y value by plugging it in there. So y is equal to 3. 1 squared minus 5 times 1 plus 6. So that will give us 3 minus 5 is minus 2 plus 6 is 4. So therefore the point of contact is 1, 4. Okay. The question goes on then to say determine the equation of the tangent. So we've got y is equal to mx plus c. I know what the gradient is. It's 1. So we get y is equal to 1x plus c. How do I find the c value? I put the point of contact in. So our y value is 4 equals 1 times 1 plus c. So c is equal to 3. Therefore, the equation of the tangent is y is equal to 1x plus 3. Okay. Example 3. Determine the equation of the tangent to the graph g of x equals 2x plus 1 squared x plus 2, where x is equal to 1 over 2. Okay, so we need to find the equation of the tangent, so we need to find the derivative, but we can't differentiate this as it is. Grade 12, so what I need to do is I need to expand it. Okay, so this will give me g of x is equal to, now this just means we got two brackets, so I'm going to FOIL it. We get 4x squared plus 4x plus 1 multiplied by x plus 2. Then I'm just going to multiply that in with each term, and the same thing goes with the 2. So that will give us 4x cubed plus 4x squared plus x plus 8x squared plus 8x plus 2. Get like terms together, so we get 4x cubed plus 12x squared plus 9x plus 2. So now we've got our function in a polynomial form that we can differentiate. So g dashed x is equal to 12x squared plus 24x plus 9. Okay, so now the gradient of the tangent would be equal to g dash of 1 over 2, because we're interested in that point. So we get 12 a half squared plus 24 times a half plus 9. Okay, so what is this? This is 12 divided by 4, which is 3. 3 plus 12 is 15, plus 9 is 24. So our gradient is 24. Okay, so y is equal to mx plus c. So y is equal to 24x plus c. Now, what we need to do now is we need to find the point of contact. So I'm just going to do this on the side, and I'm going to take my x value, plug it into here to find out the corresponding y value. So y is equal to g of a half, the original function. Hey, grade 12s, not the derivative function. So we get here 2 times a half plus 1 squared a half plus 2, and that will give us 10. Okay, so the point of contact here is a half and 10. I'm going to plug this into here. So our y value is 10 and our x value is a half. So we get 10 is equal to 24 times a half plus c. So that's going to give us 12. So c is equal to minus 2. Therefore, y is equal to 24x minus 2 is the equation of the tangent. Okay, example 4. Determine the inclination of the tangent to the graph k of x is equal to x cubed minus 3x squared minus 10x, where x is equal to 3. Now, just remember from your analytical geometry, your angle of inclination, if you have a Cartesian plane like that and you have a straight line, your angle of inclination is this angle between the x-axis and the graph, okay? And do you remember what the formula for that is? It is m is equal to tan theta, okay? So again, the gradient is equal to tan theta. So what I can do here is I can find the gradient of this graph at 3, when x is 3. Then I can just use this to find the angle of inclination. So first step is to differentiate. K dash of x is equal to 3x squared minus 6x minus 10. So the gradient of the tangent will be equal to k dashed of 3. And we get 3 squared minus 6 times 3 minus 10. So that gives us 9, 27. 27 minus 18 minus 10 gives us minus 1. Okay, so that's the gradient of the tangent. So tan theta equals the gradient of the tangent. So tan theta is equal to minus 1. Now, just remember from last year, grade 12s, what I do is I go shift tan minus 1. And I have to do the shift because I'm working out an angle. And we get minus 45. Now remember, we do not work with negative angles. So with the tan, just remember you just add 180 to it and you get 135. Your angle of inclination is 135. All right, grade 12's homework is exercise 8.7, number 2A to D. Then you've got number 3, A to C, then number 4, then another exercise, 9.7, number 5, please. Thanks, grade 12s.